Today we're going to do page 6, solve a quadratic equation using square roots. And so, solve for t. T squared equals 4. Write your answer in simplified rationalized form. I'll explain that better in just a little bit. But it's just, t squared equals 4. What squared equals 4? What can you square to equal 4? Well, your first reaction is going to be 2, right? Because 2 times 2 is 4. But what about negative 2? Negative 2 times negative 2. What's a negative times a negative? A positive 4. So that's why there's going to be 2 answers for most of these problems. Now let's do it algebraically. If we do this and we're wanting to get t by itself, what is with t right now? A square. What undoes squaring? Square roots. So if you have to square root this side to be able to get rid of the square, you plus and minus the square root of that side, because you have to do the same thing both ways. So the square and the square root undo each other, and you're left with t, and the plus or equals plus or minus the square root of 4, which is 2. So a positive 2 and a negative 2. That's how we're going to get that. Now what do you square to get negative 64? Well, your first reaction probably says 8. But what is 8 times 8? 64. We need negative 64. So let's recall, it's been a while, but we haven't done this before. So if I put r squared equals negative 64, and I square root this side, and I plus or minus the square root of that side, that takes care of each other. The r is by itself, plus or minus. Remember, let's do green. You cannot take the square root of a negative number. The negative inside a square root is bad. Do you remember what we do with that? We make it a positive, and we put an I to the outside. So it would be the square root of 64i, which is plus or minus the square root of 8i. So 8i and negative 8i. So why did we get 2 real answers here and 2 imaginary answers here? Because this was positive and this was negative. Okay, we're going to have to kind of take those in on what we're about to be talking about. Alright, it says, what type of solutions does the equation have? No solution, 2 real solutions, 2 imaginary solutions, and 1 real. So if you, I'm just looking at this problem right here. You cannot answer these questions unless the w square, or whatever squared, is by itself, and in this case they all are. So if the w square is by itself, then we look at this number. We don't care what the number is, we just care what kind of number it is. And this number is negative. So if you square root a negative, that's bad. That's when you get, I can't circle that because I'll be using it on the other ones, 2 imaginary numbers. I'm going to skip the 0 for just a second and go to the y. Y squared equals 44. Y squared is by itself, so if I took the square root of 44, this one is positive. So if it's positive, we would get 2 real numbers. Okay, and then go back to the 0. So the v squared is by itself, so we'd square root this side, we'd plus or minus the square root of this side, and the square root of 0 is just 0. If you have a positive 0 or a negative 0, that's still just going to be 0, and if you're just going to get 0, that's just one answer, so 1 real. So if this is negative, 2 imaginary. If this is 0, 1 real. If this is positive, 2 real. Okay, 6 more. So again, let's get that back to black. Square root plus or minus the square root. So r is by itself, plus or minus the square root of 7i, because there was a negative underneath there. Now you must put the square root of 7 in the calculator to see if it breaks down into anything, or just know that the square root of 7 does not break down into anything. So you're going to put square root of 7i in one box and negative square root of 7i in the other box. Make sure that the I is outside of the square root, or it's going to count it wrong. You cannot work this problem yet because the p squared is not by itself, so we have to move the 18 over. So by doing that, we're going to subtract it. Then we get p by itself, so we square root. We plus or minus square root of negative 18. That's a negative, so we're going to make it an I. So p equals plus or minus the square root of 18i. Then you put 18 in the calculator. 9, 3 squared of 2. So 3 square root of 2i. Or remember, you can put the I with the real number and then square root of 2 there. Okay. We're going to add the 15. 9, negative 9. So r equals plus or minus the square root of negative 9. Make that an I. The square root of 9 is 3. So 3i and negative 3i. You have to get s by itself. S squared right now is with 100 by being multiplied. So to undo multiplying, we divide. So we divide this side by 100, and we divide this side by 100. So we have s squared equals 1 over 100. So s equals plus or minus the square root of 1 over 100, or plus or minus the square root of 1 over the square root of 100. So s equals 1 over 10 and negative 1 over 10. Because the square root of 1 is 1 and the square root of 100 is 10. Add 80, negative 25u equals 80. Divide by negative 25. U equals, I'm going to keep that there. I know that reduces, but I know I'm going to take the square root, and if I know I'm going to take the square root and I have 25 on the bottom already, I know I can take the square root of that easily. So u equals plus or minus the square root of negative 80 over 25. So u equals, what is the square root of 80? 4 square root of 5. So 4 square root of 5 over 5, because the square root of 25 is 5. And then an I, because there's a negative on the out and negative inside. And negative 4 square root of 5 over 5. Subtract the 15. 63. Again, I know that reduces, but I know I'm going to take the square root, and I know I can take the square root of 36, so I am not going to reduce it. And square root of 63 is 3 square root of 7. So 3 square root of 7i over 6, and negative 3 square root of 7i over 6.